Today we are entering new chapter, chapter 4, integrals. Today I'm talking about the area and distance problems. First topic is the area problems. To find the area of the region that lies under the curve y equal fx from A to B. So we try to approximate the area as by the sum of rectangle and take the limit, the sum of rectangle area. We consider the curve y equal fx. The y equal fx is this is the x-axis and this is y-axis, and we have curve y equal fx like this. This curve is for function of y equal fx, and we want to find the area from x equal a to x equal b. We try to find this area S. So to find the area of the region that lies under the curve area, this area from A to B, approximated area S by a rectangle. So we subdivide the x from x equal A to x equal B. For example, we have n subdivision from x equal A to x equal B, and 1, 2, and this. This is the 1, 2, 3. This is the n division. So this length is delta x. Delta x is n divisions from A to B. So this length is b minus a over n. So approximate the area by S by rectangular area. Rectangular area is S1, S2, and Sn. So we approximate the area S is S1 plus S2 plus Sn. So this rectangular area S1, S2, and Sn. In order to find this rectangular area, as you know, the area of rectangle is the base multiply the height. The base is same for S1, S2, and Sn. The base is delta x. And the problem is the height. So how to determine the height? We can determine height, this length, or this length, or this length, any length. So I will determine the height at this length, and the area is approximated. This is x and y, and 0, and this is curve y equal fx. We try to find the area from x equal a to x equal b, and we have n subdivision from A to B like this, and I will take the height, this length, and this length, and this length. So this is S1, this is S2, S3, S4, and Sn. So S1 plus S2 plus Sn is not equal S because we have the error, this error, this error, this error, this error, this error. So actually, the S1 plus S2 plus Sn is less than S, but we approximate S by sum of the sub-rectangle. So we need more subdivision. For example, this is n subdivision, but if we have more subdivision from A to B, it's A to B. This division is very, very, very small, and this error is the more the division, the smaller the error. So it means we approximate S1 plus S2 plus Sn, limit n is approaching infinite. Is approximated as y exactly. So if I take the height as the right side, the the rectangular sum is S1 is this. I will draw again. This is x and y, and we have curve y equal fx, x equal a from a to x equal b, with subdivision and subdivision. The more subdivision n and the more accurate the s, it means the more smaller than error. So I will take the height, this length, and this is s1 and s2, s3 and sn. So s1 plus s2 plus sn is greater than s. So this subsum, in order for this subsum to be approximate s more exactly, we have to have more subdivision. So it means limit n is approaching infinite, s1 plus s2 plus sn is approximated as more exactly. So the problem, though, we only have to determine what height is. The base is fixed base is delta x is b minus a over n. But height, we can determine the height. Height may be the left length or right length and midpoint length in many cases. So next is right and left sum. It means how to determine, how to select the height. Select the height of sub rectangle. If we select the height as the right length, this is called the right sum. And if we select the height, the left value as the left value, it's called left sum. In this case, we select height, the right value. So this sum is right sum. And at this case, we select height at the left function value. So this is called the left sum. So the area A of the region f that lies under the graph of the continuous function f depends on height. How to determine the height? If we select the height at right function value, this is called the right sum. And if we select the height as the left function value, this is called the left sum. If height is chosen as the right function value, it is called right sum. And if height is chosen as left function value, it's called as left sum. The area A is limit of right or left sum. It's a right sum and left sum. Our right sum is like this. This is x and this is y. Y and this 0. And this is x0. This is a. And this is xn. This is b. And this is x1 and this delta x. Delta x is the same. This is x2, x3, and so on. The right sum is, this is the right sum. Right sum is, the base is the same. The right sum is, we select the height as right function value. So right function value is, this is f x1 and fx0. So if we select the height as right function value, it means we select height as not fx0, fx1. This is height. This is the height, and the base is this. The s1 is this region, and we select height as right value. This is left value and the right value. With right value, and we select the height right value. Not left value, this is we select height value like this. So this is delta x. This is called right sum. Right sum is Rn is s1, s2, s3, and s1 plus s2 plus s3 plus sn. The s1 is delta x multiply the height is fx1 plus delta x fx2 plus delta x fxn. So how about left value? Left value is, if we select the height as left value, x and this is y, 0 and y, and this is function y equal fx, and we try to find the area from x equal a to x0 is a to b xn. So we have n subdivision, and this is base is the same, delta x, and we select height to the left value. This left value we select height left value, and s1 is this, s2 is this, sn is this. This is right sum. So right sum, this is right sum is fx0 delta x plus fx1 delta x plus fx minus n minus 1 delta x. This is right sum. So the what is important is what do we determine the height, left value or right value, and another value. So we can select the height as another value, not left and right value. We could take the height of isorectangle to be value of f at any number xi prime, and the height of rectangle become fxi. It means we, for example, we have the curve y equal fx, the 0 and y. So we have y equal fx is like this, from x equal x0, x equal a to x equal b. We try to find the area under this curve y equal fx. We have n subdivision with the same subdivision length. Also delta x, x1, x2, x3, x4, and this is the delta is the same. And the height may be between x0 and the value of x0 and x1, not right and left value. So if we select the height fx star, f1 star, this is located between x0 and x1. The height is this value. So the rectangle is, this is the height, this value, this is s1. If we select next sample point, and this length is the height, and this is s2. So we can select the height as a function value of fx between xn minus 1 and xn. So another sum is upper sum is the lower sum. The upper sum is the maximum sample point. We select the height as the maximum sample point value on xi and xi plus 1. And lower sum is to take a minimum sample point value on xi plus xi plus 1. I will explain the graph. So this is x and this is y. This is y, and the graph is like this. This is x0 a to x0, and this is b and xn. So we have n subdivision. What is x1? This is the n subdivision. Its base length is same, delta x. This is between x0 to x1. The maximum value is this value. So this is s1, and this is s2. We take height as the maximum value. Maximum value is s3, s4, s5. S1, in case of S1, from S1 to S4, we select the maximum value, and the right value is the left value, but at S5 is the maximum value and left value. So it's different from right and left sum. So the upper sum is we take the maximum function value as a height. And the height is, this is a is limit n is approaching infinite, fx1 delta x plus fx2 delta x plus f2x3 delta x plus fx4 delta x 2 x3 x4 x5. In case of this subrectangle, which is maximum value, x4 is the maximum value, so not x5, the x4 x4 delta x. So it is different from right sum or left sum. The low value, low sum is we take height as minimum sample point value on xi, xi plus 1. I will explain by graph. So I can draw the graph. Graph is, this is x and this is y. Y and 0, and this is x equal a and x equal b, and x0, x1, x2, x3, x4, x5. So how in case of s1, the minimum value and this value is, we take a minimum value. The minimum value is the right value, and in case of s2, we take a minimum value. In case of s2, the minimum value is left value function, left function value. So left function value is, this is s2. So this is the minimum value. This is s3. This is s4. So approximate the lower sum is, s is limit x is approaching infinite, fx1 delta x is b minus a over n, and plus fx2, no, this is x1 delta x, like this. This is the sum, subdivision sum. I will take an example. The example is use rectangle areas to estimate the right and left area. So we try to find right sum and left sum under y equal x squared for axis between 0 and 1 with 4 strips and 8 strips. Same base. The base length is same. The first is we try to find area 4 strips. It means the subdivision number is 4. The firstly, we try to left sum, and this is y equal x squared is, this is x and this is y. So the y equal x squared, this is y equal x squared, and this is 1 and this is 1. And the postscript, so delta x is b minus a over n, so 1 over 4, and this is 3 over 4, 2 over 4, 1 over 4. This is the postscript. Postscript n, we left sum is, we select the height as a left function value. So in this case, we from 0 to 1 over 4, we select height left function value 0, and this is 0. And at this case, we select height as left function value, so this value, and this value, and this value. At this case, the height is 0. I didn't display. So this is the area is this area, and this area. The subdivision sum is L is left sum is delta x multiply f 1 over 4 plus for s2 is 1 over 4 multiply f 2 over 4 plus 1 over 4 f 3 over 4. So it can be 1 over 4 and 1 over 4 square plus 1 over 4, 2 over 4 square plus 1 over 4, 3 over 4 square. This is the answer. This is approximated 0.21875. This is the answer. The right sum is, I will draw the graph. This is x and this is y. X and this is y. y is this, y and 0. So y equal x squared, this is y equal x squared. This is y equal x squared. And 1 over 4, 3 over 4, 2 over 4. At this time, we select height as right function value. So S1 as this value, S2 as this value, S3 is this value, S4 is this value. This is the area sum. This value and this value and this value. The right hand sum is right hand sum with 4 strips. The right hand sum is 1 over 4 f 1 over 4 plus 1 over 4 f 2 over 4 plus 1 over 4 f 3 over 4 plus 1 over 4 f 1. So it can be 1 over 4 multiply 1 over 4 square plus 2 over 4 square plus 3 over 4 square plus 1 square. It can be 0.46375. So how about 8 strips? 8 strip, in case of 8 strips. Strips means n equal 8, so delta x is 1 minus 0 over 8. So we try to, at the first time, try to left sum, try to find the left sum. So this is the first is left sum. Sum is, this is x and this is y. And this is y equal x squared. Y equal x squared like this. And this is 1, 1. This is 7 over 8, 6 over 8, 5 over 8, 4 over 8, 3 over 8, 2 over 8, 1 over 8. A 6 over 8, 7 over 8. So we select height as the left function value. So at this area, left function value is 0. So this area is 0, and this area, 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 this area, and this area. So left sum at with 8 strips. It is delta x is 1 over 8. The 1 over 8 f 1 over 8 plus f 2 over 8 plus f 3 over 8 plus f 4 over 8 plus f 5 over 8 plus f 6 over 8 plus f 7 over 8. This is the answer. This is the answer, and this is 8. 1 over 8 square plus 2 over 8 square plus 3 over 8 square plus 4 over 8 square plus 5 over 8 square plus 6 over 8 square plus 7 over 8 square. This is the answer. So how about right sum? Right sum, the right sum is, I will draw a graph. This is x and this is y. This is y, and y equal x squared is like this. One and 1. This is 7 over 8, 6 over 8, 5 over 8, 4 over 8, 3 over 8, 2 over 8, 1 over 8. 8, 2 over 8, 3 over 8, 4 over 8, 5 over 8, 6 over 8, 7 over 8. So in case of this area, we select height as the right sum. So this area, select right function value, and this area, and this area, and this area, and this area, and this area. So this is the right hand sum is 1 over 8. over 8 multiply f1 over 8 plus f2 over 8 plus f3 over 8 plus f4 over 8 plus f5 over 8 plus f6 over 8 plus f7 over 8 plus f1. This is the answer. This is the right sum. So we take next example. Next example is let A be the area of the region that lies under the graph fx is cosine x on from 0 to pi over 2. So find the right sum and estimate the area by taking sample point to midpoint using 4 subintervals, so 4 strips. So n equal 4. N equal 4. And this is 2 questions. First question is find the right sum and find the midpoint sum. So this is right sum is the right sum. We try to right sum. I will draw the graph cosine x from 0 to pi over 2. This is x-axis and this is y-axis. This is 0. This is 1 and this is pi over 2. This curve is y equal cosine x. The fourth division. The fourth division means we subdivide the subdivided 4 between 0 to pi over 2. So delta x is pi over 2 minus 0 and 4. So delta x is pi over 8. Pi over 8. 2 pi over 8. 3 pi over 8. 2 pi over 8. 3 pi over 8. The right sum is, for this area, we take we take height at right function value, like this, and right function value, like this, and right function value, this, and right function value is 0. Correct, 0. So it means the right sum is we can find the right sum. This is pi over 8, and f pi over 8 plus f 2 pi over 8 plus f 3 pi over 8. 3 pi over 8. So the answer is pi over 8 and cosine pi over 8 plus cosine 2 pi over 8 plus cosine 3 pi over 8. This is the answer. This is the right sum. Right sum, and the midpoint sum, we try to midpoint sum. I will draw midpoint sum is. What does that mean, midpoint sum? Midpoint sum is we select height as a function value of midpoint between xi and xi plus 1. I will draw the graph again. This is x and this is y. Y and cosine x is 1 and this is cosine x. This is pi over 2. And 4 division is 1. This is a middle of 0 and 2 pi, and this is pi over 2. Pi over 8, 2 pi over 8, 3 pi over 8. The midpoint is we select height as midpoint function value. The midpoint between 0 and 2 pi is pi over 16, and midpoint from pi over 8 and 2 pi over 8 in 3 pi over 16, and midpoint between 2 pi over 8 and 3 pi over 8 and 5 pi over 16, and the midpoint from 3 pi over 8 and pi over 2 is 7 pi over 16. So we take height as function value of midpoint. This is height, and this is height, and this is height, and this is height. This value. So we can find the area A is pi over 8, f pi over 16, plus f 3 pi over 16, plus f 5 pi over 16, plus f 7 pi over 16. This is the answer. This is the answer for midpoint sum. The next topic is the distance problem. Distance is travel distance. Travel distance is different from displacement. This is only scalar. The speed, not velocity. Speed multiply time. When velocity is positive, the velocity is the same as the speed. So I will take an example. Estimate the distance drive over 30 second time interval. We have the table. Table is time, second, and velocity. Velocity and meter per sec. And it means this is 0, 5, 10, 15, 20, 25, 30. And velocity is 8, 9, 10, 12, 13, 12, 11. So we can draw scattering plot. Scattering plot is this is time, and this is velocity. Time multiplied velocity. This area is the travel distance. This is when 5, 10, 15, 12, 15, 12, 15, 12, 25, and 30. And this is 8. When t is 0 and velocity is 8 and 9. And when time is 10 seconds, this is 10. 10 and this is 10. And when time is 15, it's 12. And when t is 20, and this is 13. And when t is 25, this is 12, and this is 11. So we have to find the right sum and left sum. The right sum is left sum is right sum. Right sum is this is delta x is 5. Delta x is 5, and this is 5, and 8 plus 9 plus 10 plus 12, 13, 12, and 5 and 9 plus 10 plus 12, 13, 12, 11. So 300. This is 320. This is 335. The distance is between 320 and 335 meters. This is answer. This is we can find the range of distance. Today we discussed about how to find the area that lies under the curve y equal fx. There are some methods to find the area: the right sum, left sum, upper sum, and the lower sum, and so on. So we try to find some by examples. Thanks for listening to this video, and see you next time. Bye bye.